Hello everyone, this is Yu Chenzhou and this is Kunlong Li. So here's our project, a personalized event recommendation system using LLM reasoning. So why we want to build this? Because imagine if you want to find some events. Existing event platform only provides you a lot of similar events based on your previous click and order, so which is not good. And only if you know what event you want to search, you could search for that, and it will give you a list of events, and you have to click on it to see what's the price, what's the time to fit your own schedule, which will lead to decision fatigue and poor efficiency. So what we want to provide is use LLM model to help you digest all the information and provide the event recommendation based on your personal interests, budget, schedule, and social preference. So here's our input and outputs. The input will be a list of answers to the question we provide, which will collect the personal information like does it like outdoor activities or indoor, and is it very price sensitive? And the output will be a list of events we will recommend to you, and which will include the time, the location, and also why we recommend this event. And here's our data and labels. The first is user embeddings. We will generate the user embedding according to user's answer to the question, and which will be arrayed to some details like does it prefer indoor or outdoor? And also it will contain some limitation, like if the price is over the budget, we will set it here. And second data is the real-time event info, which we will scrap from the web on time, and it will collect all the event info we need. And the third is event embedding. We will generate the event embedding based on our event info, and which we will match to the user embedding later. So here's our system architecture. The first is the user interface part. We will generate the user embeddings based on user's answer. And second is the event processing part. The first we will scrap the URL, event URL from the web, and later we will put it to the LLM model to digest all the information. And then we will generate a prompt which includes event info. And later, we'll put that info to the event embedding generator. And the next is the third part, is the ranking part. First, we will filter all the events we don't want, like it over the price budget we want. And later, we'll use cosine similarity to match the user embedding and event embeddings. And the ranking model will give the final result to the user. Yeah.
And this is our metric of success. And we split our metric of success into two parts. One is for the internal system evaluation, and another one is the most important one, is for the final output. And for the final output evaluation, we will do an alignment evaluation based on the final output. We will take participants to evaluate whether the final output is suitable for their intent for the event or not, and to count the precisions for each recommendation. And then we will compare the final output with the LLM. Basic LLM models such as the ChatGPT chatbox. And for the embedding, for the internal system design evaluation, we have our embedding consistency check. We'll check our stability of the user embedding under small changes, as well as we'll check on the event embedding sanity by plot the distribution between different event embeddings and also the PCA plot. And this is one of our quantitative results. On the left side is the PCA plot for the event embeddings. You can see all the events spanned across PC1 and PC2 within the range. And the event cluster into groups. So it represents our event can be clustered into group and represents the event information correctly. And on the right side is the event embeddings distribution within each dimension. Most of the event embeddings are spanned uniformly or normally. So it means that our event embedding within dimensions are being fully utilized and can represent the information. And this is one of our quantitative results, which is a failure case. When the user input high-risk, high-reward games like poker or blackjack, our system accepts this input and then outputs a false recommendation about food tours and cooking class. So first, our model misread high-risk game as high novelty and high excitement and gives a response about the other things such as food tours. So basically, the main reason is our model don't have enough data to generalize this intent. And also, we don't have our a filter to detect the invalid input to block these invalid inputs. And the key takeaway is we need to build a safety classifier and constraint layer before the ranking to block these inputs. And so what makes sense in this project is that the PCA clustering can tell us that our model can interpret different events into different embeddings, and they can represent the event information correctly. And also, the success case that we mentioned in the input-output phase tell us that our model can work well. And what surprised us is that the sparse metadata, that our lack of the data in the database could turns the model into unexpected predictions and recommendations. And if we have a second chance, we will add a constraint layer and safety layer to ensure that invalid input will be blocked. Thank you.